we are studying unit circle. So when I talk about unit circle, we mean the radius of the circle will be 1. So over here, I've drawn a unit circle whose center is at the origin of the coordinate axis. Let me mark point A on x-axis. So OA is the radius, so it's going to be 1 unit, and therefore coordinates of A would be 1, 0. Let me consider a point P in the first quadrant such that OP makes an angle theta with positive x-axis. So OP is going to be 1 unit because that is also the radius. Let me drop a perpendicular from point P on the x-axis, and let me call that point as M. If I consider the coordinates of point P as x, y, then from our knowledge on coordinate geometry, we understand that PM will be y and OM would be x. So if you remember the formulas for sine, cos, and tan, which are applicable to right angle triangles, just for a recall, let me write down the mnemonic SOHCAHTOA. This should help you to remember the formulas for sine, cos, and tan. So sine theta is opposite over hypotenuse. The side opposite to theta in triangle PMO is PM. Hypotenuse is OP. Now PM is y over 1, and therefore we can say y equals 1. Cos theta is adjacent, so that's OM over hypotenuse, that's OP, which is x over 1. I'm sorry, over here y is sine theta. And x is cos theta in this case. So now what is tan theta? Tan theta we know is opposite over adjacent. So tan theta in this case is PM over OM. PM is y, OM is x. We know y is sine theta and x is cos theta. So therefore we proved tan theta is equal to sine theta over cos theta. So what do we understand from this? Number one, if you know coordinates of a point, then those coordinates can be expressed in terms of trigonometric ratios. Right? But there was one important thing: to be able to express in trigonometric ratios, we need to know the angle. For that, we need to know the angle made by the line joining the point on the circle with the center or origin. So once we have this, we can express x as cos theta and y as sine theta. Let's have a look at a sum or an example. So let me take point P over here, and I know the Cartesian coordinates of this point. Let's say it's root 3 upon 2 comma half. So if I join this point P with the center, we need to find angle theta. So how would we do that? We learned that tan theta is sine theta over cos theta. Cos theta was the x coordinate. So in this case, it's root 3 over 2. And sine theta is the y coordinate, which is equal to half. Now cos of which angle is root 3 over 2? Cos 30 is root 3 over 2. And so therefore we can say theta is 30 degrees. So from what we learned earlier, we can say coordinates of point P would be cos 30 comma sine 30. Obviously, in this case, also theta is going to be 30 degrees because sine 30 is half. Correct? Now, so you understand that if you know the coordinates of a point in Cartesian form, you can express it in using trigonometric ratios. Now, how will this help us further? Let's consider point Q such that OQ makes an angle of 150 degrees. So now this time I'm not using the Cartesian form. I'm going to use the trigonometric ratios and arrive at the Cartesian form. So coordinates of Q are going to be cos 150 degrees comma sine 150 degrees. So if we are not allowed to use calculator, then what would be the value of cos 150 and what would be the value of sine 150? That's where unit circle would help us. So what I do is I drop a perpendicular from Q on the x-axis. Let me call this point as N. Let me name this point as M. So we understand that Qn will be equal to Pm. Reason? This angle was 30 degrees. This angle is also 30 degrees. So Qn and Pm both have to be at the same height. And On length of ON will be equal to length of OM. But since ON is on the negative side of x-axis, coordinates of Q would be negative root 3 over 2 comma half, right? So now let me give you one question. Is such that OR makes an angle of 210 degrees, then find coordinates of R. Another one, if point S is such that OS makes an angle of 330 degrees, then find coordinates of S. Give your answers in the comment box. I'm waiting for your answers.